All right. Now, for the introduction to trigonometry, all right, there are lots of things I need to show you. All right, so first and foremost, I want your attention up here on the board. All right. And I'm going to talk specifically about this right triangle, SRT. All right. Now, for this triangle SRT, I want everybody to pay attention real quick. If I'm referring to T, that would be referred to as the right angle. All right. Your ratio, your trig function is never going to have anything to do with the right angle. It's always going to be one of the acute angles. Is everybody hearing me? All right. So pretty soon I'm going to ask you what's the sine of R, what's the cosine of R, and what's the tangent of R. All right. And basically what they figured out was that every single angle can be created by a ratio. All right. Now look what I mean. From R's perspective, and I really would just prefer to you listen. All right. Just listen. I don't really want you writing. All right. Because I really prefer, I'm going to say it 100 times and you're going to know it. All right. I'm going to write it 100 times. All right. So the first important thing is please let me get it into your brain first exactly what I mean. Because you're going to miss something that I'm saying if you're trying to write and listen. I promise you. I know some of you are great. You want to write everything down. But listen to me. Don't worry about it. Just listen to what I'm saying. From R's perspective, side R is referred to as the opposite. All right? Now, what do I mean? Opposite from the angle. So over here, this is the opposite. S is considered the adjacent. And T is considered the what? The hypotenuse. All right, so again, let me just come over here and just exactly what I'm talking about. All right, when you're referring to this right triangle, and I'm going to ask you about the sine of R, the cosine of R, and the tangent of R. All you're having to understand is that I'm just asking about a ratio. All right, and we're going to talk about the ratio, and we're going to talk about its opposite side. All right, we're going to talk about the hypotenuse, and this is called the adjacent. All right, and then the definitions of sine, cosine, and tangent are going to be based off of this information. All right, now believe it or not, this angle, and we'll get into more details later, but this angle is, the angle measure is formed by the ratio. So each angle has a unique ratio. So if I said, for example, what is the cosine of 30 degrees? What they're asking about is, what is the ratio of the adjacent over the hypotenuse? That creates a different angle measure. All right? So again, if I said the sine of R, and you don't even have to write this down yet because we're going to write it 100 times. I just want you to listen. The sine of R is defined as the opposite over the hypotenuse. All right? Cosine of R is defined as the adjacent over the hypotenuse. And the last one that we're going to learn this year, even though there are 3 more, is the tangent of R. And the tangent of R is defined as the opposite over the adjacent. All right? Now, I appreciate that, so you don't have to write that down yet because I'm going to do one more. All right? So sine, sometimes it's abbreviated as SOHCAHTOA. Now, I like to write it as SOHCAH and TOA. All right? So, yes, some of you have in the past heard people say Sakatoa. All right? That's just the word that helps you identify the relationship between the trig functions. All right? So, Saka, or so, SOHCAHTOA. All right? Sakatoa. All right? Is what they say. All right? And so you're going to identify as the sine is the opposite over the hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Now, the next thing I'm going to write up on the board, which is kind of confusing, is what if I were talking about, now this is what you have to listen to me on, what if I was talking about S? All right, if I was talking about S, is the opposite and adjacent the same? Not anymore. The perspective has changed. We're looking at the perspective from S, not from what? R. So, now we would say, does the hypotenuse ever change? The hypotenuse will never change. All right, because it's opposite to 90. From S now, this side now is the opposite, and ST becomes the what? That, to me, is the hardest thing for kids to realize. All right, we're talking about from a perspective. From a perspective. All right, if I'm talking about angle R, side R is the opposite. Side S is the adjacent. And T is the hypotenuse. Everybody okay with that? So believe it or not now, that's all there is. Well, not all there is, but that's the very basics of trig. All right, so if I ask you what the definition of sine is, I want you to simply tell me that that angle that is created by observing the ratio of the opposite side to what? To the hypotenuse. The cosine of the angle is simply the ratio of the adjacent to the what? Hypotenuse. And then the tangent of the angle is simply the ratio of the what? Opposite to the what? To the adjacent. That's all there is. All right? Now, what is that in all of this over here? All right? So now, let's take a closer look at the actual questions. So once again, all right, jumping down to here. Question number 1. All right? Now, the other thing, part of the reason why I started teaching kids the Pythagorean theorem, where you're doing it, pulling out the factors, is because that's what we have to do here. Do I really want to do 16 over 12 and 16 over 20 and then reduce the fraction? No, don't do that. All right, what's a common factor here? 4. So I think it's better to just write that as what? 4, write this as what? 3, and write this as 5. All right, and again, there you go, the Pythagorean triple. All right, so now the important stuff. All right, to learn it, all right, we're going to start with J. So we're going to say the sine of J is equal to 3 over 5. Now, if you want, opposite over hypotenuse is equal to what? 3 over 5. Cosine of J is defined as what? Adjacent over hypotenuse, which is defined as 4 over 5. And then we have tangent of J, which we're going to identify as opposite over adjacent, which would be 3 over 4. Do we agree? Simple. Yeah. And then I'm going to show you something in a minute how fascinating this is and how great this actually is. All right? So now I want to go to sine of L. What's the sine of L? O over H, which is 4 over 5. Cosine of L. A over H, which is what? 3 over 5. And then tangent of L. Opposite over adjacent, which is 4 over 3. 4 over 3. Is everybody with me on this? Okay, yes, again. So now, please, I want you to take out your calculator because I'm going to show you now the power of the trigonometry. All right?
Trigonometry.
All right, here we go. Listen up, please. All right, I have this now. Does everybody have their calculator? All right, now, what I want everybody to do is I want everybody to hit the mode button. All right, when you get to pre-calculus, we're going to talk about radians. Right now, we're only talking about degrees. All right, so your calculator should be in degree mode. So does everybody understand what I'm getting at? So hit mode, and it'll be degrees, radians, and I want to make sure you turn it over to degrees. You're going to get all the answers wrong. Everybody with me on this? Hit enter. Wow. Good job. Good. Don't worry, Zoe. All right. Okay, now, again, I'm trying to show you now the power of the trig. So look right up here on the board. All right, so I have, so you understand, we have sine of j. Well, I'm just giving myself more room here. Here we go. So I'm going to bring this down right here. I know. Thank you, though. All right. I don't know why I did that. All right, here we go. So look. Now, what I want to do now is I want to show you something now. I'm just going to erase this right here because I don't need this anymore. All right. And now, listen. I really want you to kind of listen carefully now because I'm now going to show you how I can figure out what the angle measure is. All right? So every angle has a unique ratio. Did everybody hear what I just said? All right, so there's only one angle that has a sine of 3/5. And now we're going to use our calculator to figure out what that angle is. So again, now, in order to solve this, all right, this is not sine times j. Is everybody hearing me? It's not sine times j. It's what angle has a sine of 3/5. That's what the question is. Hear what I'm saying? What angle has a sine of 3/5? Well, the calculator will tell you. Now, how do I do the calculator? Remember, how do I undo addition? Subtraction, multiplication, square. So everything that you're telling me is an inverse operation. So if I'm trying to solve j, there must be an inverse operation. Well, the inverse operation is simply this symbol, sine -1. Now look up here on the board, make sure you see that. All right. Now, if I do the inverse sine of the left, I have to do what? Inverse sine to the right. That's how you eliminate the sine. You don't eliminate the sine by dividing. That doesn't mean sine times j. Is everybody with me? All right. So now this crosses out. So j is equal to the inverse sine of 3/5. Now everybody type in the inverse sine of 3/5 and tell me what comes up on your calculator, please. 36.86. 36.86 roughly degrees. That means that triangle J, come on, look up now, you got to be hearing me. That means this angle right here is 38 point whatever we said, 36.86 degrees. Everybody hearing me? Hey, you guys hearing me on this? Right? So that's why the trig is super important. The calculator has in its program every single possible angle there is from 0 to 180, and it can tell you exactly what angle is created by that ratio. Does everybody understand what I'm saying? So I know now J is 36.86. All right? That's all right. Now, I'm looking at how do I solve for cosine J? What do you think I have to do?
Cosine -1.
Now we say, I want you to sound better. I want you to say it's the inverse cosine. I want everybody to type in the inverse cosine of 4/5. And what do you notice?
The same.
Exactly the same. How did I know it was exactly the same? Because it's the same angle. It's the same angle. And then what you're going to do is you're going to do the inverse tangent of 3/4. And now your brain is supposed to make a connection. It doesn't matter what trig function I'm looking at. It's always going to give us what? The same angle. Because that angle is constant. Hello? Does everybody understand what I'm saying? Now listen, it's better to ask me now than it is in a few minutes, because it's going to get a little bit trickier as we go down. Anybody have any questions with that? Now, we're going to take a look at L. So how do I figure what L is? Inverse sine of what? Do inverse sine of 4/5. Now, how did I already know what the answer was without you telling me?
Because all the angles add up to 180.
All the angles add up to 180. Or, even better, listen to me, these two angles are complementary. So I could have just done 90 minus J to get L. But the point is now I'm trying to show you on your calculator, look how accurate it is. Do you see what I'm saying? Now again, I'm trying to explain to you the power of the trig. Power of trigonometry is allowing you to take any angle measure and any side and be able to figure it out without doing what? A squared plus B squared equals C squared. You don't need A squared plus B squared equals C squared anymore. All right? The trigonometry will allow me to solve or to find all the missing angles and all the missing sides. All right? So now, if I'm looking at question number 2, just to make sure you're hearing me. Let's just do number 3. All right? Now, the first thing I should do is divide everything through by what? Divide everything through by 12. So when I do that, that crosses out. That becomes what? 2 radical 3, and this just becomes what? 3. All right. Now, I want the sine of J. Somebody tell me what the sine of J is. 3 over 2 radical 3. I don't care about rationalizing the denominator right now. That's not the lesson. All right? Just leave it like that, because I don't care. I know we can rationalize. Now I want the cosine of J. Which is what? That's what I'm asking. Square root of over. Now in this one we can just change it to 1/2. Are we good on this? And then tangent of J. And what is tangent of J? 3 over radical 3. Everybody good on that? Very good. Here we go. Sine of L. What is sine of L, guys? Radical 3 over 2 radical 3, which is 1/2. Agreed? Cosine of L. 3 over 2 radical 3. And then tangent. Radical 3 over 3. Now hopefully you can start to see relationships. The sine of J is always equal to the what? Cosine of L. Sine of L is equal to cosine of J. All right. Now, for those of you guys who recently took the SAT or in the SAT in the past, there's a couple questions dealing with that information right there. But if you'd have known that, it's not that much. It's really not that difficult. All right. Just the basic definition. All right. That's how easy the SATs are now. All right. Anybody have any questions with that ratio? All right. Now we're just going to practice. All right. Now, the reason why I'm saying you're practicing on this is because typing this in the calculator is kind of annoying. All right. So you're going to do inverse sine. All right. Now, when you do inverse sine, look, guys, it's going to be the parentheses already opens up, correct? Yeah. Then you have to do 3 divided by, open another parentheses, or it's going to be wrong. Right? Because you're dividing by 2 radical 3. So it has to be, if you're doing it on the calculator, I'm just going to write it out. And then I'm not telling you anymore. And then some of you are going to not always get the wrong answer, and you don't know why. It's because you didn't listen right now. All right? So when you type this in, the sine of J, you would type in inverse sine 3 divided by parentheses 2 radical 3 close parentheses. Should be 60 degrees. Should be 60 degrees. If you didn't get 60 degrees, then that just means you don't know how to use your calculator. All right? Now, just for practice, go down and do cosine, inverse cosine, and make sure you're getting 60 degrees. Right now, because I'm not trying to rush through, we have more time. All right, so that's why I'm spending a little bit of extra time today making sure you understand the how to type it on the calculator. Now, I want cosine J to come out to be what also? 60. If it doesn't come out to be 60, that means you don't know how to type things into your calculator. And then just practice with tangents. All right, and all of them should be what? 60 degrees, which forces L to be what? 30. And then just practice inverse sine of 1/2. All right, let's see what happens. Everybody good? What?
I don't know why. Oh, yeah, I'm big. Uh-oh.
That'll do it.
For 10, it's only like 79 points.
So is it automatically does the multiplication?
I can check your phone.
Parentheses.
Why did I do that? Did I have to put another parentheses?
Well, I wouldn't even. No, I would have crossed those out. So it's just the
Oh, okay.
right. That's why.
So it didn't divide it?
No.
You didn't
Yes,
divide
it
it.
does.
Oh, wait.
And for ones where it's just a radical and not like 2 radicals, you don't.
Okay. Now listen. Do me a favor. All right. I'm scrolling down to the questions now. All right. Scrolling down to the questions. So here we go. Question number 1, guys. Here we go. Look at number 1. It says, find the measure of angle T. So highlight angle T. And then we're referring to angle T right here. All right. Now, the easiest way to do this is to identify what 2 other things are given. So this right here, come on, stay with me. This is the what? So again, opposite. Then this right here is the what? Adjacent. So what trig function involves the opposite and the adjacent? Tangent. So everybody's going to write down on their paper. tangent t is equal to 14 radical 3 over 34. Now, just because I want you to get used to it, I want you to write t is equal to the inverse tangent of 14 radical 3 over 34, and that's approximately, somebody said about 35 point, and it says round to the nearest tenth, so we'll just go with that. 35.5. Yeah, right around 35.5. And again, if you're not doing that, let me know.
Oh, well, I have a question. When would we use like regular?
We'll get to that. We'll get to that. We're looking for the angles right now. Yes.
Do we only use it in parentheses
When it's on
when it's a
the
radical?
when it's on the denominator.
Yes, yes, that's a good question. Hey, let me say one more time because kids don't understand this. Look up, look up, look up. Look up. Hey, he's correct. Now listen to me. I'm trying to tell you about order of operation. So the calculator is going to do what? 14 times the square root of 3 and then divide by 34. So I don't need parentheses on this one. Right? However, I'm going to just go back to the other one because I think it's important for you to listen. For example, number cosine of L over here. If I type in, everybody's got to watch, look up please. If I type in 3 divided by 2 radical 3, it's going to take 3 and divide it by 2, and then multiply that answer by what? Radical 3.
Oh yeah.
Is everybody with me?
Yeah.
Now please, I'm going to save yourself a bunch of time if you pay attention to me right now. Look up. This is why I tell all my advanced kids you shouldn't do it that way. Watch what I'm showing you now. If I want 3 over 2 radical 3, please stay with me. I'll save yourself a bunch of time if you listen, Alessandra. Come on. Look up, look up, look up. I'm going to save you a bunch of time. Instead of doing all the parentheses, here's what you should be doing. And people look at me like I'm crazy. Does everyone understand those two things are what? They're equal. They're equal. All right, but most kids do not know that. So I'm asking you to make sure you understand what I just said. I don't do parentheses because I understand order of operation. Most kids do parentheses because they don't understand order of operation. I'm trying to make sure your brain understands these two things are equivalent. Most people would argue with me. They're not the same. They are the same. Because what am I doing? 3 divided by 2. And then I'm dividing that by what? By radical 3. Or I'm taking 3 and dividing it by
2 times radical 3.
Parentheses 2 times radical 3. Exactly correct. So I can save myself a bunch of time by eliminating the what? Parentheses if you understand order of operation. Now everybody's supposed to look up at the board and say, yes, I understand that these two things are equivalent. If you don't understand, we got a problem.
Why do you divide it by radical 3?
Because that's what this is telling you to do. 3 divided by radical 3. It's just these two things are connected by what? So it seems like your brain would type it in as 3 divided by 2 times radical 3. But the calculator would do 3 divided by 2 and then multiply by radical 3. All right, now just to make sure I'm here, you with me, look up one more time because I'm going to make sure this is correct. So just to show you what I mean by this, 6 divided by 2 times 3 is what? 1. So now do on your calculator, 6 divided by 2 times 3.
9.
It's 9. It's not correct. If you type on your calculator 6 divided by 2 divided by 3, guess what the answer is? The correct answer. Do you understand what I'm trying to show you now? I'm trying to get into your brain. Most people that I work with don't understand that concept. I'm trying to make sure you understand that concept. Does everybody get me on that?
Yes.
All right? This is equivalent to this, even though there's no multiplication. I have people argue with me all the time about it. right? You're dividing by 3 and you're dividing by 2. Even though there's a what there? Multiplication. All right, that's why you got to be smarter than your calculator. They design SAT questions and ACT questions to thwart people who use calculators. All right? If you don't understand the calculator, then you'll get it wrong. All right? So you have to be careful. All right? Now let's get back to work, now that you understand that completely. So everybody look at number 2. I'm looking at T. I'm trying to find the measure of angle T. So what is 7 with respect to T?
Opposite.
What is 18?
Hypotenuse.
So what trig function is opposite and hypotenuse? Sine. That's how simple. Sine of T is equal to 7 over 18. Then what? T is equal to the inverse sine of 7 over 18. Could somebody tell me approximately to the 10th?
22.9.
22.9 degrees. Beautiful. It's really simple. Really simple. Really, really simple. You guys scream out there all day long, trust me, because I sit here and roll my eyes all day long. What are you guys screaming at?
Each other.
Oh my gosh. So annoying. All right, I hear all of it. All of your little whining and your high squeaking noises. I hear it every day. Yes, you are so loud. All right. I have the video to prove it. All right, here we go. Angle T, here we go. I'm still solving for angle T. So angle T, what is 34? And what is 87? Hypotenuse. So what do we got? Cosine of T is equal to what? 34 over 87. So T is equal to the inverse cosine of 34 over 87, which is about 66.9. All right, 67 degrees. I'm not arguing over rounding. Okay? Anybody have any questions with that? I told you it's very easy once you understand the definitions. All right. Now I'm trying to see if there's anything more difficult. There it would be good. I want to drop down here now. Okay. Now, how much time do we have?
1 minute.
1 minute. Okay. So here is your responsibility for tonight. Listen. Your responsibility for tonight is 4, 5, and 6. Finish that out. And then just for my benefit, all right, yeah, I really want you to write the ratios for question number 2. But before we do that, let's remind ourselves that I can divide everything through by what? 8. So this would be a 4, 5. Wow, so isn't that the same as number? That's the same. So here's what I want. I want you to write the sine, cosine, tangent for J and L for number 2. And then I want you to do 4, 5, and 6. And then because I'm adjusting our exam, we won't have to rush through, and I have an extra day to do this material for tomorrow. So we will finish up tomorrow on the bottom, and you will understand again the beauty of trigonometry.
Wow. I like it.